Well, good evening. Welcome to Space Oddities. Thank you for joining us this evening. We hope you're all well. Good to see you here. So, on tonight's show, with NASA's Psyche spacecraft doing not exactly a flyby, but an approach at the orbit of Mars on Friday, we thought this evening we would delve into the Psyche mission, which is the name of the spacecraft, but it's also the name of the asteroid that it's flying towards. And this asteroid is thought to be composed of precious metals, which may be more valuable than the entire world economy. So we're going to delve quite deeply into the Psyche mission this evening. Also this evening, Lou is going to be telling us exactly how planets are formed. And we've got our regular features. We've got Constellation of the Week. We've got Space Numbers of the Week. We've got Dave doing his week in. And we've got Einstein of the Week, making a reappearance after a few weeks of me not finding much to laugh about on the internet. God knows there isn't much these days. So anyway, joined this evening by the usual suspects. Hello, everybody.
Hi there.
Hey.
And I'm afraid Daz can't be with us this evening. He's got family commitments, but we will struggle on without him nonetheless. So without further ado, we're going to get Michael to tell us all about NASA's Psyche mission. So, Michael, over to you.
Okay, just bear with me and I'll get myself in order.
And if you have any questions about any of it, of course, please put them in the chat or in the comments after the show if you think of your...
Okay, right. Thank you, Andy. So I'm going to talk about Psyche tonight, both the asteroid and the spacecraft that is flying towards it, as Andy said. So this spacecraft was launched on the 13th of October 2023, and it will make a Mars gravity assist flyby this week. This presentation gives us an overview of the mission and the target asteroid 16 Psyche. So this is an artist's impression of the asteroid based on ground observations. I'll come to that in a bit. But the actual asteroid itself was discovered back in March 1852 by Annibale di Gasperi, an Italian astronomer, back in March 1852. From an observatory in Naples. He names it.
We lost. Oh, there we go.
Right, you're back, Michael. We lost you momentarily. Can you hear us? Hello, Michael. Right, okay. Well, we appear to have lost Michael for the moment. So what we will do is we will carry on without him, unfortunately. So
I think that guy was giving us the evil eye. I think that's what happened.
Yeah, he doesn't look a very certain fellow, does he? So we will carry on. We'll go straight over to Dave. If you're ready, Dave.
Oh, okay, sure.
The weekend. We're trying to regain contact with Michael later.
Okay. Yep, no problem. Hang on a second then. See if I figure this out now.
I'm back.
Oh, you're back.
Oh.
All right. Well, let's go back to Michael then.
I'm sorry. Can I just bear with me? I won't be in a second. Sorry about. Don't know what happened there.
No.
Okay. Let me get myself together.
As we always say, the perils of live broadcasting.
Yes. What am I doing? Oh, I'm not really.
Okay. Well, look, we'll carry on with Dave for the moment. While you get...
Okay. Yeah, sorry about that.
Sorry, viewers.
All right. Hold on.
Yeah, all right.
Mm-hmm. All right, Dave, over to you.
Okay. All right. Let's see. You are not seeing anything?
No. Hang on 1 second. Okay. So,
there we go. Okay.
There we are.
All right.
Okay. Over to you, Dave.
Okay, so right this week. Okay, a lot happened this week. So I'm going to run through some of these kind of quick because there were a whole bunch of things I really wanted to at least mention, but I didn't want to make this too long. So, but let's get started anyway, which is kind of interesting. So on May 10th in 1879, the largest meteorite ever known to have ever fallen in North America landed on this farmland in Estherville, Iowa. So right, pretty much smack dab in the center of the continental United States. This is a big old meteorite. It was it ends up breaking into three pieces just before it hit the ground, and someone, an observer, actually saw it come apart, and it was and the town there actually has a monument which is about on the spot about where it landed, and where the largest piece landed, and they also built a little statue of the meteorite, and they've got a meteorite museum there. Apparently, when it when it hit, I guess basically, or when it broke apart, I don't know, but it broke a lot of windows in the town, in the nearby town. It did a lot of things. There were some boys who were fishing at a lake there, and they said the lake suddenly was getting sprinkled with all these little pebbles and pieces falling in the water. So I guess when it broke apart, it actually scattered pieces all over. Anyway, it was quite dramatic. But like I said, it was the biggest piece. And then there was a whole big thing about people taking some of the bigger pieces and burying them or hiding them because no one knew who owned the pieces, and people wanted to keep them or claim them for their own or whatever. Anyway, it was very interesting. So the pieces ended up weighing 431, 151, and 106 pounds. The three biggest pieces. Mostly iron, nickel, and some phosphorus and sulfur, but this is probably not unlike probably what we're going to see when we get to Psyche. Metal. In other words, a big metal honking meteorite fell. So anyway, quite a that's an interesting an interesting.
Did it actually impact, or did it explode midair?
So it broke into three pieces, and then all three pieces hit the ground enough to basically bury themselves. They took a while to find them.
Wow.
They buried themselves into the ground. But apparently, for years later, people were looking for little pieces of these things because when it broke apart, a lot of small pieces came flying off. And like I said, these guys, I guess these boys were fishing in a lake, and all of a sudden all these, these things started peppering into the lake. These little pieces of the meteorite.
Wow.
And somehow it exploded or broke apart almost right overhead someone who was watching it. They said they saw it break into three pieces, and then the three pieces went off in their own directions and landed in a few areas. But the largest piece, the 431-pound piece, which was 200 kilograms roughly, right? That landed where that little marker is. So anyway, kind of cool. OSIRIS-REx. Okay, so that left Bennu and started heading back to Earth on May 10th in 2021. So, excuse me, 5 years ago. Probably you may remember that if you look at the bottom picture there of the sample arm going down, hitting the surface. Collected a huge number of samples. Well, from what they expected, they were hoping to get at least 60 grams of sample were their goal. They ended up with 121.6 grams of samples, so many that they actually closed the lid before they ended up measuring it because they could see pieces of the samples already floating out of the sample container. It was so full that it was overstuffed. So they just closed the lid. They had a plan to measure it and make sure they got enough samples. And when they saw pieces floating out, they were pretty sure they had more than enough samples. So they closed it up to make sure that they weren't going to lose more. Brought it back to Earth and landed on September 24th, 2023. And also, you may remember watching that land. That was pretty exciting. Okay, this was just last year, and I remember this really well. It was pretty cool. So Cosmos 482, which was supposed to be a Venus probe, and failed. And became named Cosmos 482 because that's what the Soviet Union did. Was they named things Cosmos missions if any Earth orbiting mission they were naming Cosmos, but they also, if they failed, they just named it a Cosmos and sort of acted like it was supposed to be an Earth orbiting mission all along, and they meant to do that. But this one actually ended up orbiting for over 50 years before it finally re-entered. And when they they did spot it, and it did. They did end up every day. There was these predictions, more and more, trying to get pinned down more and more accurately where it was going to actually hit on the Earth, and it ended up hitting in the Indian Ocean. You can see in that little map in the center there. But the interesting thing about that was that what it was a Venus probe that was supposed to go into the Venus atmosphere. So it was actually designed to survive the kind of conditions way more harsh than what it would find in the Earth's atmosphere. And so the fear was that this thing was going to come over land, and that the actual descent module would survive completely the reentry into the atmosphere and end up doing some damage somewhere. Luckily, it ended up falling in the ocean, and so we don't really know what happened to it, but it's somewhere at the bottom of the Indian Ocean.
I think I remember that they were trying to see if they could activate its parachutes, but after 50 years in space, those parachutes were not going to work. So no.
That's right. And they were supposed to work automatically, but under the Venus conditions and stuff. And again, whether they would have worked on Earth or not is probably a moot point, because after 50 years in space, the mechanism probably wasn't working anymore. So that would have been something, though. If they actually parachuted down. That would have been impressive. Yeah. Okay. So all right. So 1959. So May 12th. 67 years ago, today, was the first positive measurement of solar flare protons. Was made from a balloon at 30 kilometers. But the story of the balloon is pretty interesting, because it was launched by the University of Minnesota. And it turns out that the University of Minnesota actually had hired Jean Piccard, who was a famous balloon aeronaut, and his wife, who was also an aeronaut. They hired them for a lot of various reasons at the University of Minnesota, but he started a balloon program there. And the University of Minnesota now is one of the biggest schools with a balloon program. It still goes on, but they helped them build and design the balloons. They would attach instrument packages to the balloons, and they'd send them up into the stratosphere, and they make these kind of measurements. And that's, you can see the balloon on the left there. But the really funny thing is that these balloons were built by General Mills, which actually had a balloon division, which I never knew until a couple days ago. But they had a balloon division that designed these big high altitude balloons. I'm General Mills, and I don't know if on the British side this is anything, but it's a food company. I mean, this is Betty Crocker, and I didn't know they did anything but made breakfast cereal and stuff like that. But apparently they had a very active and successful balloon division in Minnesota, weird, in concert with the University of Minnesota. So,
wow, never heard of General Mills, I'm afraid. But
okay, oh, you haven't? Okay, because to me and probably to Lou also, that's probably a little shocking, because really it's a food company. I mean, I've never known it to do anything but do food.
Oh yeah, and cereal is its big
right cereal, right? And Betty Crocker was the General Mills spokesperson. So that's kind of anyway. Well, okay, so it's interesting to the Americans anyway. May 14th, 1933, first rocket launch by the American Interplanetary Society. And remember, this is not too long after Goddard launched his first liquid rocket. They built liquid rockets, liquid oxygen fueled rockets, and launched them from Staten Island, which back in 1933, there was a large part of Staten Island that was still pretty much undeveloped. There still is a good chunk of Staten Island, but of course it's it's part of New York City. It's way more developed than it was then. But there were places where it was safe to launch these rockets. But you can see the very sophisticated building. They had like I said, the liquid oxygen, liquid propellant rockets, which were very brand new. They actually ended up becoming the American Institute of Aeronautics and Astronautics after a decade or so of launching these rockets and developing these rockets. But this particular one, the very first one, it went up to 76 meters, and then the liquid oxygen tank exploded.
Oh,
so it was a sophisticated liquid oxygen tank, but not perfect liquid oxygen tank.
76 meters.
76 meters. Yes. Yes.
Okay.
A couple hundred feet, right?
That
Something
much.
like that. Little, yeah, 230, 240 feet, something like that. No, nothing huge. But still an actual, liquid fuel rocket that hadn't been a lot flown by that point. And this was done by, not necessarily, not quite amateurs, but an amateur society at least built these and launched them. So this was the very first one. Okay, Skylab Space Station, May 14th. Amazing, that's an amazing accomplishment. The first U.S. space station. To those of us used to, the Mercury and Gemini, and then even the Apollo, the little cramped quarters, all the astronauts sitting right next to each other, and that the Skylab was amazing. I mean, I don't know, just you see all the room they had. It was unbelievable. But they
Was
they
that
had
an empty Agena?
it was an empty upper stage of a Saturn V that
Oh,
they
okay.
used. So they used the Saturn V to launch because it was so heavy, and they used this. They had used the stage. I think that's right, of the upper. Anyway, when it first launched, it was actually damaged on launch. One of the solar panels and damaged it. And the first group of astronauts that went up there had to actually make some repairs. They came up with some clever mechanisms to repair the thing that the astronauts brought up with them and actually used. It operated for 24 weeks. 3 different trios of astronauts manned it, and it was really quite it was quite something. Anyway, it was quite an achievement, and there was a lot of really sort of fun video television appearances, and the astronauts doing all their, well, you can see like this this strong man holding the the guy upside down, and they would play with water. They would do little flips in their little their big compartment there and stuff. And anyway, so yeah, that was well, like I said, it was something. May 15th was like a lot of stuff happened on May 15th. Don't ask me why. But on 1618, Kepler discovered the third law of planetary motion. He credits this as the day that he actually came up with it in Linz, Austria, and that is the law where the cubes of the distances are proportional to the squares of the periods of the planet's orbits. That building where he actually made the discovery is actually still standing, and I actually visited it a few years ago. And you can go inside and you can walk around, and there's a society that I guess meets there every week that discusses planets and gravity and stuff like that. And apparently when I walked in, I just missed it probably by a few hours. I didn't know this until I got there, but there was a notice on the wall about this meeting, and I thought, well, that would have been pretty neat to actually meet people talking about that. But anyway, again, a big big moment in our understanding of the solar system and the universe, really. Stanley Miller. Okay, so this is probably, you could consider this perhaps the origin of exobiology, I guess. And that is Stanley Miller published his paper in 1953, where he basically set up this lab experiment where he put a bunch of methane, ammonia, thought to be at the time the atmospheric composition of the early Earth, sort of the primitive early Earth atmosphere, and applied electric discharges to it, and ended up with amino acids and hydroxyl acids and urea, organic compounds associated with life. It was quite a moment. It got reported as that in the popular press, it got reported a lot that he had actually created life in a test tube, which wasn't true. But it was still an eye-opening experiment, because no one thought it would be that simple to produce amino acids, especially things that common to life. Now we know amino acids are they're kind of all over the place, and I guess they're a lot easier to produce or synthesize or come about naturally than we thought. But at the time, this was quite an eye-opening experiment, and again, it led to a lot of the earliest ideas about how life formed on Earth, and of course, on other planets, and how life might be possible elsewhere in the universe.
And it was
They-
it's amazing that that set of experiments is still controversial to this day. Because obviously there was a lot of religious opposition to it. And
yes.
there still is. You still read on social media, religious people saying it was all a fake and a fraud and everything else. But it wasn't. it was, for its day, it was an advanced experiment. Compared to what can be done now, it seems very primitive. But you're right that it was the first real steps in serious astrobiology science. So but it's
I mean, I think it really paved the way to just to the idea that we can look at creating these compounds with and of course it led to all sorts of different combinations of chemicals and electric discharges and pressures and temperatures and all sorts of things and trying it in different media like clays and things like that and finding all these different ways that you could produce these building blocks of life and right, it really opened our eyes to how possible this might be and how common this might be. Okay, on May 15th again, so 1958 now, so 68 years ago, Sputnik 3 was launched, by far the biggest thing launched into space. I guess before that they launched Laika, the dog, into in space, and it had a compartment that could hold the dog and all. But this had let's see now, what did I say? Oh, it had over 2 metric tons. It weighed over almost 3 metric tons. No, it weighed over a metric ton. It had 1,330 kilograms. Sorry, I was reading the pounds. Okay, by far the heaviest satellite ever orbited at that time. And it was, I mean, really, this was again, another eye opener, really, because up to that point, what they'd launched, all was pretty lightweight, small stuff. And again, this is only 1958. I mean, they just launched Sputnik, and suddenly the Soviet Union was launching, this thing that weighed over a ton into space, and it was really scary for everybody. Apparently, because now all of a sudden it was like, well, if they can launch that much mass into space, they can launch a pretty big weapon into space, and all of a sudden all bets were off on what was safe. And anyway, it was like I said, it was a little scary. However, this was just contained experiments, had about 12 experiments, all powered by battery. To study the upper atmosphere, magnetic fields, radiation environment, cosmic dust, and collected data for about a week to a month, depending on the experiment. The only real failure was that the onboard tape recorder failed. And so they could only send data when they were in sight of their ground stations. And the plan was to have 24 hours or full orbits of data, just one after another, on the tape recorder, and just download the data every time they came by the ground stations. But they could not do that. So they ended up, I believe, sending the data back at 1 bit per second, I think, or something like that. Still, even so, they still managed to get an awful lot of data back to the. No, that's wrong. That's wrong. It was a higher rate than that. But they did manage to get back a lot of data on the upper atmosphere and the environment up there, back to Earth. Okay. And
can you just go back a second?
Yeah.
If you look at the picture on the right of the actual spacecraft, or a replica of the spacecraft, or whatever it is, you can always tell the old Russian spacecraft because they used old trombones as antennae.
Yeah, right. Right.
Along with the obligatory tractor parts and bits of old vacuum cleaners.
That's what always was the joke about Soviet spacecraft. But I heard that scientists who went over there and looked at them said they looked like, inside looked like Swiss watches. They were so they were quite actually
quite mechanical,
quite something. Yeah. And okay, so other international, China became only the third nation to land on Mars. And this was again only 5 years ago with the Zhurong rover. And there's a picture from the rover, and there's a picture of the landing site after it landed. and they actually could pick up the landing site. It's a false color image, but they could bring out exactly where it landed, and you can see it left a mark from the rockets. And again, a very successful mission. It sat there and deployed the rover 8 days later. Only third country ever to land on Mars, and achievement.
Yeah.
And finally, May 16th, 1969, Venera 5 dropped into the Venus atmosphere, descended by a parachute, returned data from the atmosphere down to let's see, what did they say? About 18 kilometers roughly before it finally succumbed to either the temperature or the pressure. No one knows exactly what happened. There's conflicting reports about whether the Soviet Union thought that this was going to make it to the surface. It seems pretty clear that at that point they knew that the pressures and temperatures were too high for this probe to survive, but I think they'd already built the probe, and they just figured they'd get it down as far as they could in the atmosphere and get as much data back as they could. Although I think they reported initially that it actually had landed on the surface, because I guess they wanted credit for being the first spacecraft to land on the surface of Venus, but it obviously did not, based on the data that it returned, and it didn't get to didn't get down to a pressure anywhere near the surface pressure. But it sent data for 53 minutes and gave us a lot of the earlier information about the Venus atmosphere. And you see they celebrated with a stamp and kind of a classic Soviet Union, Anyway, anyway, I guess that's it. So thanks.
Thank you very much, Dave. Thank you very much. I just want to show you a comment that I think will mean more to Americans than it will to us, but I'll put this up from Fred. And Fred says there were old General Mills commercials shown on 60mm film at some of the Psychotronics film festivals at Fruit.
Really?
Okay. That I certainly don't remember, but that's great.
Yeah. Thank you very much, Fred. There we are. Blast from the past.
Tell Tom to dig those up and archive them.
Yeah.
And if you find any commercials about their balloon division, I would love to see that.
Yeah. I'm just wondering what their balloons were made out of if they were a grocery company. It makes me wonder.
It's the same thing they make at the plastic grocery bags out nowadays. They develop.
Yeah, maybe. Yeah, absolutely. All right. Well, I'm pleased to say Michael has rejoined us after communications blackout for a little while.
Yeah, I'm not sure.
Michael.
Yeah, I'm here. So I'm just going to share my screen again.
Okay.
Here we are.
In case you weren't with us earlier, we're looking into the Psyche mission. Michael's going to tell us quite a lot about the Psyche mission.
Yes.
And the asteroid it's chasing down.
Yeah.
Okay. Right. So off we go.
Okay, thank you. As you said, this presentation is about Psyche, unveiling the core of a lost world. A NASA mission to explore the solar system's most extraordinary asteroid, a metal world that may be the exposed heart of an ancient planet. The Psyche spacecraft was launched on the 13th of October 2023, and this week on Friday it will make a Mars Gravity Assist flyby. This presentation is an overview of the mission and the target asteroid. So let's go through this. This is an artist's impression of the asteroid based on ground-based observations. They know that there's two deep depressions on the surface, and it's not quite a spherical object in size. The asteroid was discovered back in March 1852 by Annibale de Gasperi, who was an Italian astronomer working at an observatory in Naples.
Otherwise known as Smiler.
Yeah, yeah. He named the asteroid for Psyche, the Greek goddess of the soul, who was born mortal and married Eros, the Roman Cupid, the god of love. Because it was the 16th asteroid to be discovered, it is sometimes referred to as 16 Psyche. De Gasperi was known for discovering asteroids and his contributions to theoretical astronomy. This is an image of his telescope that I found online. Not very good, I'm afraid, but this was the northern dome of the Naples Observatory in 1929. So he actually found 9 asteroids with this instrument, apparently. So Psyche itself, we are now calling it a metal world like no other. And that's, as we say, based on the current observations. Psyche lies deep in the asteroid belt between Mars and Jupiter. From astronomical observations, scientists have discerned that Psyche is an unusual object, likely rich in metal. Many questions about its origin and composition remain. The Psyche mission will be the first to study this kind of planetary object up close. This is Psyche is in the solar system. You see, they've got the inner planets in the center. Psyche sits neatly about halfway between the orbit of Mars and the orbit of Jupiter. And this is probably the best image that we've had so far from the ground. This was an image by the Very Large Telescope in South America in 2019. So compared with other asteroids, if you look at Ceres on the top left of this diagram, Ceres is around 940 kilometers across. Psyche is around 226 to 230 kilometers in diameter. So so quite a small one compared with Ceres, but still, amongst the largest asteroids in the asteroid belt. So that's the one there marked by the circle. Okay, going on to the spacecraft itself. This is an artist's impression of how the spacecraft would look as it approaches Psyche. Very large solar panels and a sort of a box-shaped satellite in the middle. So this is the spacecraft in the clean room a couple of years before launch. You can see quite a complex, piece of equipment with the technicians there for scale. It's quite a large piece of, as I say, it's quite a large piece of equipment. So that's how it was a couple of years before launch. And this slide shows how big the Psyche spacecraft is in relation to a normal tennis court. So another picture from the clean room now. This is one of the solar panels being unfurled. It's quite a massive setup. This is just the part of the one part of the solar panels, because there's 2 more panels to be unfurled in the middle of the panel. So again, on to the science instruments now. The science goals for Psyche are to understand iron cores, a previously unexplored building block of planet formation, look inside terrestrial planets, including Earth, by directly examining the interior of a differentiated or layered body, which otherwise would not be seen. Explore a new type of world, one made not of rock and ice, but significant amounts of metal. So the science instruments on board. The first one is a magnetometer. Here it is being installed by the technicians in the clean room again. There's also a gamma ray and neutron spectrometer. This will determine if the elemental composition of the metal-rich asteroid Psyche. So that will tell us whether it is the metal-rich which we think, asteroids that we think. And we'll also have multispectral. This is the gamma ray neutronic spectrometer. Close up of the instrument, quite technical by the looks of it. And this is one of the lenses in the multispectral imager. There's two of these lenses on the spacecraft. So that should so it's a pair of identical cameras equipped with filters and telescopic lenses to photograph the surface of the asteroid in different wavelengths of light. The cameras can take pictures in parts of the spectrum visible to the human eye, as well as near-infrared wavelengths of light beyond what humans can see. Okay, so also the Psyche spacecraft is also a test bed of various ideas. One of them is solar electric propulsion. So the spacecraft has 4 Hall effect thrusters that use electromagnetic fields to expel charged atoms or ions of inert xenon gas that in turn create thrust, training a blue glow of xenon. Only one thruster is used at a time, providing up to 240 millinewtons of thrust. The amount of force that you would feel holding the weight of one AA battery. And Psyche carries a 7 22-gallon tanks of xenon propellants of up to 2,400 pounds or 1,085 kilograms. So that's solar electric propulsion being used. And another test bed is the deep space optical demo. So this is an item bolted to the side of Psyche, pioneering technologies demonstration. NASA's deep space optical communication experiment uses a near-infrared laser. DSOC is the first test of high bandwidth optical communications between Earth and distance far exceeding the Moon. Okay, so that's another close-up of that particular instrument. And another picture of the satellite in the clean room. This it's the tube on the lower right of the lower middle of the spacecraft in this picture. So yeah, it's actually an 8-inch aperture telescope using for the laser. So that would be the laser communications. The transceiver will transmit high-rate data to Earth using its 4-watt near-infrared laser and receive low-rate data from Earth using an attached photon counting camera. Okay, so this is another artistic impression of how that works with the laser beaming data back to Earth. Another idea on this mission, the Psyche will rely on the telecommunications system used to send commands to and receive data from the spacecraft to conduct gravity science. By analysing the X-band radio waves, the spacecraft communicates with scientists can measure how the Psyche asteroid affects the spacecraft's orbit. So the mission itself, a SpaceX Falcon Heavy rocket with a Psyche spacecraft on board launched on Friday, 13th of October 2023 from the Kennedy Space Center in Florida. This is a diagram of how the orbit will take the Psyche satellite out to Psyche itself. And the key milestone this week is the actual gravity assist approach to Mars, and then it will reach Psyche, the asteroid, in around 2029. And on the way, it's taken a few photos of other objects, planets and stars. This is the Earth and the Moon from about 180 million miles away. This was taken in July 2025 as it calibrated its imager instrument. So you can see a blow up of the Earth and Moon there at the inset. Another one taken in January 2025. This is showing Jupiter and Mars, and it even picked up 3 of Jupiter's satellites, Io, Callisto, and Ganymede in this image, if in the inset photo. So quite a good camera for that. And in the news recently, Psyche actually captured 4 images of 3I Atlas over the course of 8 hours on the September the 8th and 9th, 2025, when the comet was about 33 million miles from the spacecraft. Okay, so it's a 6-year voyage to the asteroid belt, as I launched in October 2023. Then 15th of May, that's this Friday, Mars Gravity Assist a critical slingshot maneuver to reshape the trajectory. And another particular photo I like, this one taken of Mars on the 3rd of May, only a few days ago. That's a colorized image of Mars from the Psyche spacecraft from a distance of about 3 million miles. The spacecraft itself will actually come within 2,800 miles of the Mars's surface, and for its gravitational boost. And traveling at some 12,333 miles per hour to boot. Okay, this will give the gravity assist. I'll put this picture in to show roughly how close it looks from the Psyche spacecraft to Mars itself. I've taken this screenshot from NASA's Eyes on the Solar System program online, which is an excellent resource. Okay, when it gets there, Psyche will enter orbit around its namesake asteroid and to begin most detailed study of a metal world ever attempted. The spacecraft will be captured by Psyche's gravity in late July 2029. The entire mission is conducted from orbit, mapping and measuring from above. And this is, so as I say, July 2029, arrival and capture by the asteroid. And that will, the mission will go until 2031, sorry, which will be the end of the 26-month orbital science campaign. The orbits, Psyche spacecraft will do various orbits at different times. The orbits are named alphabetically by the highest A to the lowest D. They don't proceed in alphabetical order. Rather, they proceed based on the changing amount of sunlight illuminating the asteroid surface during observation and the kind of science that can be done. The mission also has a built-in margin into its orbital operations timeline in case engineers need to address operational issues. So that's 4 different orbits over the 26-month observational period. Okay, so science objectives. Determine whether the asteroid Psyche is a planetary core or if it's an unmelted material. Determining the relative ages and of of regions on Psyche's surface, determine whether small metal bodies incorporate the same light chemicals elements, including sulfur, potassium, and silicon, that are expected to be present in Earth's high-pressure core, and determine whether Psyche was formed under condition more oxidizing or more reducing than the Earth's core. In Psyche's case, these terms refer to whether there is a lot of oxygen present in the asteroid's metal compounds, in other words, oxidized, or little or no oxygen, in other words, reduced. Okay, at the end of the mission, the spacecraft is not designed to land or crash into the asteroid. Instead, it will continue to orbit the asteroid indefinitely, acting as a permanent, dormant artificial moon, similar to how NASA's Dawn mission ended at Ceres. And that's it. So thank you very much.
Thank you, Michael. Fantastic. Any idea how long it's going to remain operational around Psyche?
It says 26 months, but whether that can be extended, I haven't found any details of that.
Right.
So, yeah.
But it's a fascinating world, as you say. It may be the core of an ancient planetoid.
Yeah.
We won't know till the spacecraft gets there. But
Yeah.
It's assumed that it's made of lots of precious metals with a total value of more than the world's entire economy.
Yeah, that's right. But we've got to wait, unfortunately, till the 2029 at least to find out.
Yeah, absolutely.
But think of it, if that were true and some Elon Muskish company decided to go mine it and bring back who knows how many millions of tons of material, then the stuff would be worthless.
Oh, of course. We'd be eating tuna out of gold cans.
Right.
Yeah, I mean, it's
as we do in America, yes.
Of course. That's why you're so muscular. You have to lift them up.
Yes. Yes.
That must be it.
So anyway, viewers, if you've got any comments or questions about the Psyche mission, I'm sure Michael or us would be more than happy to answer them. You can put them in the chat, or you can put them in the comments of the video afterwards. And there we are. And
so, is there I'm sorry, Andy, can I ask a question? Either for Lou or Michael, if it's if it wasn't a melted core, but it's this huge amount of metallic substance, I mean what else could it be? I mean, what could concentrate that much metal?
Yeah.
It's possible that it was not, in fact, a melted core, but it formed near the sun early in the development. It's also possible that it was, completely destroyed, smashed on impact, and it's scattered its fragments around, which later accreted together. I like the differentiated planetary core hypothesis best, but these other two are floating around.
Yeah.
It's not a collapsed Death Star, is it?
Oh yeah, that was the other one.
Yeah. And the thing I was just thinking about as well is the fact that we think that the outer planets have not always been in the orbit that they're in now, but they've been closer into the sun and closer into the sun in the past. So the asteroids might have done the same, got close to the sun. You don't know, and we don't know for that, definitely.
No, absolutely. Yeah, so anyway, really interesting mission. So can't wait, got to wait a little bit till it gets there, but there we are.
Yeah.
Okay, just before we go any further, a quick word from this video is sponsored by Picastro. It's like Instagram for space nerds. And many thanks to Tom McCrory for sponsoring Space Oddities. We owe Tom some congratulations on two fronts. Not only has he become a staff writer for Astronomy Now magazine, but he also had a picture photographed as NASA's Astronomy Picture of the Day. So many congratulations to Tom for a round of applause.
Yeah.
Tom couldn't be with us tonight because he's too busy basking in his own glory.
Signing autographs.
Autographs, fighting off the paparazzi, that sort of thing. But yeah, well done, Tom. We're proud of you, and can't wait to see your articles in Astronomy Now. And you know, not everybody gets to have their photos as NASA's Astronomy Picture of the Day, otherwise known as APOD, because they receive thousands of submissions, and they chose one of Tom's beautiful images of a nebula for Astronomy Picture of the Day. If you're not familiar with Astronomy Picture of the Day, you can search for it on the web, just NASA Astronomy Picture of the Day, or NASA APOD will find it, and you go back a few days and you can see Tom's image. So well done, Tom. Well done indeed. So moving on. Anyway, if you would like to support Space Oddities, you can do so in the time-honored fashion by buying us a coffee, because astronomers' lives matter. And you can either scan the QR code here, or you can click the link in the chat to go to the Buy Us a Coffee page, and you can buy some much needed caffeine. Don't forget, summer's approaching, and you will need to get your Space Oddities t-shirts. It's obligatory under a new bylaw. So you know, don't fall foul of the law. Go and buy your Space Oddities t-shirts. You don't want to see anybody in any trouble. And they are £20, including UK postage and packing. Can't say it fairer than that. Good quality stuff. Fly the flag for Space Oddities. And, you know, we've still got some quite cool spring nights, so you may want to consider a hoodie as well, which are from £40, including UK postage and packing. And if you're outside the UK, please add £10 to the total value of your order. So, so there we are. And talking of planets, question for you. If you could choose a destination in the solar system for a spacecraft to visit in the near future, or however long it takes to get there, which destination would you like to see a spacecraft explore next? So don't answer this question in the chat, but please put it in the comments of the video after the show, and there we are. We'd be interested to see where you want to go next in the solar system. Quick one-word answer, guys, from you. What should be the next target for planetary exploration?
Enceladus.
Enceladus?
Venus.
Venus?
Uranus from the Decadal Survey.
Uranus from the Decadal Survey, absolutely. Roger?
Well, let's try Titan.
Hey.
Yes.
Oh.
I didn't want to say.
But if you're familiar with a YouTube channel called What About It, which is a wonderful YouTube channel, mainly based around space flight and rockets and SpaceX and stuff. But last week he did a wonderful analysis of the Dragonfly mission, really detailed stuff, really interesting. So you should check that out. Called What About It? You'll find it easily enough. Okay, let's move on. I think we're going back to Dave now. So, sorry, we've done Dave.
Nope.
So to speak. I guess it's me. Right. Okay. Just give me 1 second to set myself up here. And
Had me worried, but
okay. So what we're going to do now is we are going to go to Space Numbers of the Week, where I give you some numbers related to space, and you have to tell me what the number relates to. So here we are. So today's Space Numbers of the Week. Is everybody's ready? The first number, 60 billion. Now, what could that possibly relate to? If you know, viewers, put it in the...
If Catholics ruled the world, that would be our population.
Funny enough, no.
Must be,
it's the... I think
kilometers.
it's the average person's estimate of NASA's budget.
It's how much Elon Musk is worth.
Oh, he's worth more than that. Yeah.
On a bad day.
Right. Yeah. Any ideas? No.
We don't have any missions that cost that much.
60
So.
billion.
Yeah.
60
The
billion.
cost of the Nancy Grace Roman telescope.
No, good God.
No.
No.
No, we need that money for the new ballroom. So
Yeah. How much is the cost of the ballroom?
So nobody knows, basically.
That's
Okay.
right.
No.
No one does know.
This is an interesting one. It's the combined mass in solar masses of the heaviest black hole binary yet discovered in the galaxy above 402 BCG.
Of course, that was my second guess.
Yeah.
60 billion solar masses. Wow.
Yeah.
Okay.
So this is very interesting because the results of a galaxy merger, the two black holes have been orbiting each other for a few tens of millions of years, which beautifully astronomers described this week as a new relationship. In another few tens of millions of years, the pair will merge into a single black hole with almost 60 billion solar masses. Now, it's almost 60 billion because some of the solar masses are radiated away in the form of gravitational waves, of course.
Right.
When those orbits degrade, you won't need a gravitational wave observatory to detect them.
No, absolutely.
Our bodies will be stretched.
You'll get You'll pick it up on an FM radio, probably.
Yeah.
So this makes it among the contenders for the heaviest black hole in the universe. So when it forms this single black hole of nearly 60 billion, the record so far is well, there's a lot of uncertainty about it, but certainly TON 618 weighs in at 66 billion solar masses. And does anybody know the diameter of TON 618 in miles?
You mean the event horizon?
Yes, the diameter of the event horizon.
Yeah.
How about I don't know, 1 light year?
No, it's not that big. But it's still pretty big. The diameter of the event horizon of TON 618 is estimated to be 40 billion miles. So that is incomprehensibly huge for a black hole. So this binary actually smashes the record for the previous biggest, heaviest binary black holes. In fact, it's double. The previous record holder was a black hole binary that had a combined mass of 30 billion. So this is amazing. Okay, next number, 1.7 million.
7 million.
This is a rather depressing figure. You're not going to like this at all.
Is that the
It's NASA's actual budget. Is that
I'm going to say something like that?
No, okay. This is the number of satellites planned to be launched in satellite constellations over the next few years.
No.
Oh my gosh.
Yeah. These are only applications filed, I hasten to add. The actual number that are actually launched may be just a few 100,000. But applications have been filed by various countries and organizations to launch 1.7 million satellites over the next few years.
Wow.
Yeah. And I can give you a breakdown of that, actually. eSpace, 300,000. Starlink, 42,000. Chinese constellations combined, potentially 37,000 plus. Kuiper, 3,236. And numerous smaller filings from companies and governments worldwide. So this actually leads to the next number, which is 3 times. No, okay. Well, because of all of these satellite constellations, this is the potential increase in brightness of some parts of the sky due to satellite constellations.
Oh gosh.
With so many satellites all reflecting sunlight, the sky develops an additional diffuse glow. So some parts of the sky may become 3 times brighter. So this is all rather depressing stuff.
Are these largely almost entirely communication satellites?
Yes. Yes.
Yeah, they must be, right?
Yeah, they are. Yeah, they're certainly not scientific satellites. So yeah, these are mainly internet broadband constellations. So yeah, depressing, eh? Okay, let's move on to something quite different. 341.
I know that number. That's the number of bank holidays you have in England.
No. We have twice
No.
that. And in Spain, 10 times that number, actually. Okay. Now, this is the number of little red dots so far discovered by the James Webb Space Telescope.
Oh,
We've talked about little red dots.
High Z galaxies.
Yes,
Little red dots.
they are thought to be, well, they're very early on in the universe. They're very red, and they're very compact, and it's thought to be a nascent black hole surrounded by very dense gas. That's the latest idea, but there are other ideas. So 341 have so far been discovered. You may remember, I think we did this on Space News Weekly actually last week. They discovered one of them has X-ray emissions as well. And this is fantastic news for identifying what they are, because it goes along with the idea that they are black holes shrouded in dense gas. And what they think has happened is that the gas has thinned out, allowing X-rays to escape, if you like. So this does lend credence to the idea that they are nascent black holes very early on in the universe, within the first couple of 100 millions of years of the universe.
Okay.
Surrounded by these cocoons of really, really dense gas. So there you are.
I don't know what the energy distribution of material falling into a black hole is, but we usually hear about it being very high energy X-rays and gamma rays.
Yes.
So I'm thinking that the red color here, well, it is, did you say this is James Webb?
Yes.
Okay, so we don't really know what color.
No.
Right.
So there we are. So yeah. So okay.
But at 100 or few hundred million years after the formation, does it mean that these black holes were formed basically in the Big Bang? I mean, it doesn't sound like that was time to form a black hole.
Well, now I'm glad you asked that question, because these may be the results of so-called migration traps in active galactic nuclei. And towards the end of creating a video for the Space Oddities channel all about black hole migration traps. So keep your eyes out for that, viewers, and I'll tell you all about migration traps in great detail. But an absolutely stunning story. You won't want to miss that. So look out for that on the channel soon. But basically, Dave, it's the results of repeated mergers, building black holes much faster than we thought possible, with the traditional accretion method, where a black hole just sits there and just swallows up.
Yeah, sounds fast. Right.
But if you're going to build a supermassive black hole that way, it takes a really, really, really long time. And these migration traps are basically areas in the accretion disk of an active galactic nucleus where you get repeated mergers happening, and it happens much, much quicker in just a few tens of millions of years. So, but anyway, keep your eye out on the channel. Click the notification bell to get notified of when that video will go live. Should be within the next week or so, hopefully. And an absolutely amazing story I've got to tell you. So next number. Now we get to NASA's true budget.
Quintillion. All right. How many? Wait. Billion.
What are the units,
trillion?
though? What are the units? 700 quintillion.
That's 10 to the what? 18.
Oh boy.
Yes.
All right. Well, it's not the
Does
mass
that help
of
you,
the
Lou?
universe in kilograms. Is it a mass?
No. It's an actual number of something.
Sorry, I'm back in the Catholic theme again. Sorry.
Yeah.
It's 700 quintillion. So the bits of data expected to return by the Vera Rubin telescope.
Oh, nice guess. Totally wrong, but a nice guess. No, this is actually a new estimate of the number of terrestrial or rocky planets in the universe. Yeah, there are estimated to be
Let's
that.
hope yes, yet.
Wait. If you're gonna do that, you have to say plus or minus.
Yeah. Okay,
80
plus or minus
quintillion or
5.
something.
Plus or minus.
12.3.
Oh, that's interesting.
Yeah.
Now, that's in the visible universe?
Yes, in the visible universe. Yes.
Okay.
Yes. Okay, next number. 0.02 seconds.
Ooh.
Oh.
The attention span of our audit. No, I'm just sorry. I
Steady,
apologize.
steady.
Oh dear.
Mm.
Let's see. What light is it? Have to do with the speed of light?
No.
0.02.
Yeah.
2 seconds.
No. Any guesses?
No.
Okay. This is the time taken for one rotation of the fastest spinning neutron star.
Oh, flipping heck.
Wow. I was going to guess a
Oh.
rotation, and then I said nothing to rotate
Yeah.
that fast, so never mind.
Yeah.
So,
Yeah. So
wow.
the fastest spinning neutron star means that one rotation takes 0.02 seconds, which is crazy.
Oh my gosh.
And of course, anything else rotating at that speed would just fly apart.
Right.
Mm.
Right.
Because it's a neutron star, of which a teaspoonful would weigh 1 billion tons. It's pretty good at keeping itself together. So
Now, is there any estimate of? I mean, it still must have some flattening, right? I mean, even a neutron star spinning at that speed, you'd think would have some. Is there an estimate of sort of how much it's flattened, or is it maybe not? I don't even know.
it's not. It's not.
No.
Because it has an outer layer, a solid outer layer of probably iron, and then there's a thin crust of iron, and under that there's neutronium, which is this weird quantum state of matter, which consists largely or almost entirely of neutrons. It's so rigid that if you had a slip of just a few millimeters on the surface, it would generate more energy than the sun outputs in a year.
Oh wow.
Yeah.
Okay.
So, are these pulsars? Is that how we know their rotation speed?
Well, I mean, it's. I mean, obviously, pulsars are neutron stars.
But how would you know the rotation speed if it wasn't a pulsar? Is what I'm thinking.
Yeah, that's true. That's true. So yes, it must be a pulsar. Yeah.
Okay.
So absolutely amazing. I mean, there may be faster ones, but we don't see it because it's not a pulsar. So
NASA has done some sonification, they call it, of neutron star. I mean, pulsar pulses.
yes.
And when they get up to speeds like this, it's just this high whine. You can't
Yeah, that's right.
Sure.
distinguish.
Right.
Right. But basically, Dave, to answer your question, these are far too rigid to have any flattening at all.
Wow.
Even
wow.
gravity can't compress them further than they're already compressed.
And do they have an estimate of how big it is?
Oh, well, a typical neutron star is going to be about the size of Manhattan in diameter.
Yeah, I guess right. If it gets too much bigger, it probably just becomes a black hole, right, or something like that.
No, that it would have to have more mass for that to happen.
Oh, even more, even bigger. Okay.
Yeah.
Well, big versus massive is the issue.
Well,
Yes.
if it's a neutron star, I mean, I guess you know how big it is. You know what the mass is if it's all just a neutron star. But there's got to be a limit to how big a neutron star can be before it just collapses under its own.
Well,
Gravity, right?
then you come to something called electron degeneracy pressure, which means it can't get any smaller. It's already at the theoretical smallest that it can be, because the pressure from the electron degeneracy pushes outwards. It's like any other star. There's a battle
Okay.
between outward pressure and gravity.
Right. No, I just wondered if there was an answer. But so it's the size of Manhattan. That's good. I'm picturing this thing spinning 50 times a second, and it's kind of insane, really.
Yeah, it's amazing. But
gravity always wins.
But if I've got the figure right, I think this is correct. If you were to drop a ball from the height of a meter onto the surface of a neutron star, by the time it hit the surface, it would be traveling at 1,200 kilometers per hour. From a height of 6 feet, it would be traveling at 1,200 kilometers per hour by the time it hit the surface. These are bizarre objects, and there we are.
Unless you're observing it from afar, where your time in a gravity field like that is going to be.
Yes, the dilation.
Oh well, there's that too, right?
Yeah, absolutely. All right, next and final number. I think 27.
I know that number too. That's the number of people we called to ask if they'd be on the show before we got to Dave.
Wow.
Only 27, huh?
Oh, shoot me. Go ahead. Just shoot me.
Yeah.
Thank you, Lou.
Yeah.
I'm sorry, Dave. That was uncalled for.
Okay, so astronomers have been looking with the apparition of Comet 3I Atlas being our third known interstellar visitor. Astronomy has been looking back in the archives of lots of different astronomical surveys to see if they could spot any previous interstellar visitors that we missed. And they've done this with the aid of AI. And this is the number of possible past interstellar visitors that the AI has discovered in archive survey data. 27.
Nice.
Yeah. So,
I mean, not surprising, really. I figured we had 3 in just,
few years.
Not many years, right? And so that can't be just some. Yeah, exactly. It's not surprising at all. That's pretty cool.
I think it's pretty cool. Yeah. Oh, we got one more. 40,000 kilometers per hour. 40,000.
The rotation rate of the Earth?
No,
it's 40,000 kilometers a day, right?
Oh yeah. Well, yeah, right.
Yeah.
1,000 miles or 14. Okay.
40,000 kilometers an hour.
No. Well, this is one for you, Lou. It's the speed at which Voyager 1 is receiving.
So that would be equivalent to something like 3 AU per year. That's the only number I carry around.
Yeah. Yeah, absolutely. So I always try and include a Voyager question for you. So
Thank
there
you.
you are. So that brings us to the end of Space Numbers of the Week for another week. Hope you enjoyed that. And some fascinating facts.
Oh, we lost dear leader.
Whoops.
I'm back.
No,
Lou, there's only one person you're allowed as American to use the term dear leader for, so just remember that, okay?
Oh, forgive me. Whoever's listening into this, forgive me.
Anyway, some fascinating facts and figures there. And the ones about the proposed satellite constellations are really depressing. But
yeah,
it is. I'm writing my congressman.
But don't forget, Blue Origin. Amazon. Blue Origin basically have been touting their constellation of satellites, and so far they've only managed to get up about 200, I think, out of the proposed 1,000 odd. But they've got a bit of a problem, and I think this is brilliant news. By June, their contract with the FAA said that they had to have launched 2/3 of the constellation by this June, and they're nowhere near it. So if they haven't done that, there's a good possibility that they may have their contract cancelled, their permission to launch cancelled.
all right.
So they've been turning to ULA and SpaceX, saying, "Please help us out. Please help us out." because their New Glenn rocket has been so delayed, and now it's grounded because of 2 anomalies in 2 flights in a row. Investigations underway, so they're not going to make their target of launching 2/3 of the Constellation by this June. Whether the FAA will then turn around and say, "Oh, go on then, we'll let you," is open to question. We'll have to wait and see. But I don't see how they could bend the rules to that extent, because if they do it,
I have a solution.
what's that?
Let them launch. Get their millions of satellites into low Earth orbit. Crowd that area up like crazy. They are going to collide. The space situational
Yep.
awareness is
I was
already
thinking the
a
same
problem.
exact thing.
As they collide, their pieces will smash out into low Earth orbit, and it will
The Kessler syndrome.
yeah, it will kill everything up there.
Yeah, but then that's even more surface area to reflect sunlight, right?
Darn.
Lots and lots and lots of pieces.
Dave,
Of course, their orbits won't last as long, but
And then nobody will be able to launch anything. So all our wonderful science missions won't be able to launch either. So there we are. All right then. Thank you for that. And what we're going to do now is go over to Roger for our weekly look at the night sky and the viewers gallery for this week. So take it away.
Yay!
Okay.
There we go.
Let's go.
Go.
Right. There we are.
So we're working our way through May now. Ooh,
Yeah.
How did that happen? Right. Okay. So we're currently in the waning phases at the moment. Oh, haven't put that up last week. But we're working our way through, so it's not looking too bad. But we've still got Jupiter over towards the west now, with Venus looking quite nicely after sunset, fortunately. So that's not too bad. But looking over towards the eastern skies, we're starting to see the summer constellations coming up through, with Vega coming up nicely, with Altair and Deneb coming up around about midnight. So that's not looking too bad at all. Right. But before sunrise, we do have a few planets coming up through. We've got Saturn and Mars coming up before sunrise. Mercury's now just on the other side, with Uranus coming shortly afterwards. And obviously we've got Venus and then Jupiter following on a few hours later. So we've still got a few objects to see in the morning sky. So have a look out if you do get that opportunity. We've also got M5 looking quite good in its position of when we can get some nice clear skies. It's not looking too bad out there at the moment. So we've got superior conjunction for Mercury, and we've also got the Moon and Mars coming up through later in the month, not too far away. And we've also got the perihelion Moon, when we get it slightly bigger and brighter, but not an awful lot. And if you didn't know this, we've also got one of the minor dwarf planets here. We've got Ceres opposition on Friday, so that might be an interesting thing to have a look at. It's in Virgo, so it's a good location to have a look at. So maybe somebody can get a picture of it. Hint, hint. Right.
Roger.
So we've also
Roger.
Roger. Yeah.
Oh right. Oh, I thought you might try out your new telescope.
Oh, I will. I'm not sure that's gonna cut it, but I will give it a shot.
Okay. So we've got a lunar occultation of Beta Tauri, although it might be a bit difficult for some of us in the northern hemisphere, but southern hemisphere might get more of an opportunity to have a look at that. But there's always something being blocked by the moon. And we've got a few remnants of the Anaquariids, and we've got the Lyrids peaked up around as well. So there might still be an opportunity to see something streaking across the sky. Right. We've still got a little bit of activity on the surface of the sun to look at. But we've also got some coronal holes coming towards the facing the Earth in another couple of days. So keep an eye out for that as well. So there may be some interesting opportunities for some auroral activity. And then we move on to the gallery. Well done to those that have managed to put some images in. We've got some solar images from Michael Murphy, and this was on the 6th of May. Obviously, we don't have too many on this day to have a look at, but well done to Michael for capturing it on that day. And then we've managed to get one from 4 days after on the Sunday, just past. And as you can see, quite a bit of a difference.
Yeah, I like that.
Yeah, difference that 4 days later, we've got all this activity going on. Amazing.
Nice image.
And then we've got one from Jerry, the Draco triplet, which is a bit different from the Leo triplet. So we've got this one with his Ritchie Christian RC6 telescope.
Whoa.
Oh, wow.
Holy moly.
That's nice. That's
That's
nice.
beautiful. Wow.
What kind of telescope took that?
Well, a 6-inch Ritchie Christian. So
Wow.
a little
Jeez.
bit more focal length than the one that you've got there. But you should be able to do that with your C11, Lou.
I'll give it a shot. I have no idea where to find this, but I'll figure it out. It's called the Draco
triplet.
triplet. Okay. All right, Roger,
So-
you're on. I'm throwing down the
That's a
Challenge.
challenge coming on. Right. Okay. But got some interesting features there. So you've got like a diffuse one there. You've got an edge on, and you've got a nice spiral. All
beautiful.
within a nice alignment there.
You better hurry, Lou, before those satellites get up there.
Yeah, absolutely.
Yeah.
Okay. So we've just got this one by me, which I took the other morning of a daytime moon.
Nice.
Just the as it's
It's a very
fading
pleasant
away now. Yes. So it's just a quick grab shot, so to speak, of a moon in the daytime. And that's what we have for this week's Gallery and Night Sky.
That's nice. That's nice.
Thank you very much, Roger. Thank you
Yeah.
very much indeed. So just the customary reminder, if you would like to see your images in our weekly gallery, then attach them to an email, 1 image per email, please. Otherwise, Roger gets confused. And mail them to gallery@space. And not only do you get to see them here in the Tuesday gallery, you also get your own gallery on the Space Oddities website, which, just to remind you, is https://spaceoddities.space. Couldn't be easier.
Yes.
And while you're at it, why not join our Patreon community, where for just a few pounds every month, you'll be supporting the science that we try and bring you on the Space Oddities, and you get loads of goodies as well. So head over to the Patreon page, which is patreon.com/Space Oddities, and join the community there. We'd love to have you on board. And as always, I'm duty bound to say that every bit of money that we receive for your very kind donations, and by the way, thank you very much to Sandra and Gerard tonight for donating, much appreciated. Every bit of money that you donate to Space Oddities goes to a good cause. It goes to keeping the channel going, because we have bills to pay like every other channel does for various things. So thank you so much for your support, and we do appreciate it, because we'd like to bring you Space Oddities for as long as we possibly can. But for that, it's a sad fact of life that we need the money to do it. So any donations appreciated. If you'd like to make a donation directly, you can click the super chat icon, which is the one under the chat window, the one with the $sign on, and that will allow you to make a donation directly to us. And thank you very much indeed. And don't forget the t-shirts and the hoodies, as well as our current merchandise. We hope to expand the range of merchandise before too long. I know we keep saying that, but we must definitely do something about giving you a bigger choice of merchandise. And we'll get onto that soon. All right then. For now, we've talked a lot about planets tonight. They've come up in one way or another. So very interesting topic, of course, is how do planets form in the first place? And I'm going to let Uncle Lou talk you through that one.
Let's see, you should be able to pull it up there, I guess.
So so here we are. So what's all this about then?
There we go. Well, it seems I've stumbled once again into a topic that could be an entire university course. So these things really challenge me. So we're going to do this in two parts. Today we're going to talk about kind of general formation theory. Yes, I see nebular theory come up there. Yes, we'll talk about that. And planetary migration and some of the basics. And then next week, we'll break it down for each planet and talk about the unique characteristics of all these planets. How do you get all these different planet sizes, masses, compositions, orbit? How do you get all that different stuff from just this homogeneous gas cloud? So we'll talk about all that next week. So let's see. Let's get on here with it. How do you build a solar system? Well, so the first thing you need to know about building a solar system is that it won't last. I don't just mean the destruction of the inner solar system, Mercury, Venus, Earth, Mars, in 5 or so billion years when the sun leaves its home on the main sequence, turns into a massive red giant star. Of course, that will happen. We've seen it in other solar systems, but long before that, in fact, long before today, the solar system is changing. Planets move in and out of their current orbits, disrupting orbital resonances and the orbits of other planets. Chemistry changes, temperatures change. Our sun is constantly changing. It all changes. There is not much, if perhaps anything, in the solar system that can remain stable over the lifetime of our star. So as we go into that, just get comfortable with that. It's not going to stay there for long. The best current theory of the solar system formation that we have is, as Barry is telling us here, the nebular theory. This was first proposed by Kant and Laplace in the 18th century. The nebular theory remains the cornerstone of planetary science. It explains how the chaotic raw material of the molecular cloud was sculpted into the ordered architecture we observe today. About 5 billion years ago, a massive star ended its life as a supernova, shooting the building blocks of potential solar systems outward and creating even higher order elements in its wake. From this supernova remnant or molecular cloud, our solar system formed. It formed from a large rotating cloud of gas and dust called a nebula, which collapsed under its own gravity and flattened out due to conservation of energy, with the densest material in the center forming the sun and the remaining flattened disk eventually condensing into planets, moons, and asteroids. This explains, for example, why the planets orbit in the same direction that the sun rotates. Did you know that? It's true.
Oh.
As the central mass, the sun, reached a critical density and the temperature of about 15 million degrees Kelvin, nuclear fusion ignited through what is now called a proton-proton reaction. This process converts hydrogen nuclei into helium-4 nuclei, releasing a gamma ray, photon, and neutrino in that process. And that's why the sun shines. The resulting solar wind kept sweeping outward, clearing vast quantities of remaining gas from the inner disk regions. It just gets more exciting and more exciting. As this nebular collapse proceeded, the overall density increased. Temperature gradients within the disk created a critical boundary, the frost line. Beyond the frost line, water ice could condense. Inside that line, only refractory, rocky, and metallic minerals could survive. Outside it, ices added to the building materials available for planet formation because they could condense. Small bodies that formed inside the frost line became asteroids. Ones that formed outside the frost line became volatile-rich comets. So the resulting protoplanetary disk then was not uniform. In addition to temperature differences, density waves, turbulence, and compositional gradients set the initial conditions that would determine where and what kind of planet could eventually form. Planet formation began initially through electrostatic attraction of dust grains and condensed ices, and these grains grew to micrometer size. From there, I think it's still unclear how we get planet formation that reaches meter to kilometer size, but beyond meter kilometer sized objects, however, planet formation was a combination of accretion through gravitational attraction and collisions. As the nebula collapsed, it heated up and began to spin, conserving, again, angular momentum. The sun must have lost some of its angular momentum in this process, either through a strong solar wind or possibly interaction of the sun's magnetic field with ionized material in the disk. This would be breaking the sun's rotation and producing the sun's rotation rate of about a month at the equator that we know of today. The solar wind blew the closer in lighter elements, such as hydrogen and helium, into the outer solar system, providing most of the material to form the gas giants. This, plus the frost line resulting from the decreasing temperature with distance from the sun, is the primary reason there are two classes of planets. There are the terrestrial planets, Mercury, Venus, Earth, and Mars, which also share similar attributes, and the Jovian planets, Jupiter, Saturn, Uranus, and Neptune, also sharing similar attributes. So the early solar system was basically a chaotic mess, okay? Objects accreted material and grew in size until they got smashed into bits by other objects. It was a race to see which object, or if you will, protoplanet or planetesimal, could become large enough to withstand the constant bombardment of other solar system objects in various stages of their own growth. Once objects became large enough, gravity accelerated their growth dramatically, and this stage is called runaway accretion. So, frequent collisions during the early solar system produced intense heat that kept planetesimals molten. As small rocky debris accreted through high velocity collisions, this accretion heating, as it's called, combined with radioactive decay of short-lived isotopes like aluminum-26, which has a half-life of something like 700,000 years or something like that, they melted the interior of these bodies. This molten state enabled materials of different densities to separate, allowing heavier, denser materials like iron and nickel to sink to the center and form a core, while lighter, less dense silicate materials, oxides and volatile compounds, they rose to the top, forming the mantle and protocrust. This process of differentiation, that's what it's called, yielded the dense iron-rich cores of the inner planets. These energetic collision-heavy conditions persisted throughout the early stages of planet formation, which is believed to be roughly about 100 million years. So, because water ice and other volatiles could not condense in the inner solar system, this limited the amount of solid material available to make planets. Although initial planetary embryos formed somewhat quickly, maybe 1 to 3 million years, the overall development of the inner planets formed relatively slowly because there simply was not enough solid material for rapid growth. Beyond the snow line or the freeze line or frost line, temperatures were low enough for water ice, methane ice, ammonia ice to condense. This dramatically increased the amount of solid material available, perhaps by a factor of 3 to 5. So their large, icy, rocky cores formed rapidly, allowing them to quickly, gravitationally capture hydrogen and helium from the surrounding nebula. Objects that did not accrete to form large enough bodies to differentiate retained the chemical composition of the original condensed solar nebula. And This is important because this means that the oldest comets and meteorites hold clues about the early solar system. So that's why we send spacecraft to Psyche, for example. So the challenge, when we're talking about 4.5 billion years, and so the challenge is, as with much of astronomy, astrophysics, and planetary science, is to build a model of the universe, in this case, the solar system, incorporating the physics that we understand, and to run that model forward in time over billions of years, in this case, to end up with the solar system that we see today. In other words, the planets in their current orbits and with their current physical attributes. It turns out early simulations of planetary formation struggle to match today's orbits because they largely assumed that planets formed and remained in their current locations. And what you're seeing here in the upper graphic, you see what the solar system looks like today: Mercury, Venus, Earth, Mars, an asteroid belt, and Jupiter. But early models of the solar system, trying to integrate forward for these 4 or 5 billion years, produced very different solar systems. So what's going on? Why did these models not work? All right, so anomalies in the orbits and composition of the inner solar system, including Mars' size and mass, Mercury's large core, cratering on the moon, and the composition of asteroids, it turns out can best be explained by migration models of the gas giants. The giant planets, the gas giants, did not always occupy their current orbits, according to these models. 2 landmark models reveal a dramatically different early solar system, one that is defined by gravitational chaos and some degree of planetary wandering. The Grand Tack and the Nice models explain much of the peculiar architecture of both the inner and outer solar system by proposing that Jupiter and Saturn migrated inward and then outward in the early protoplanetary disk, acting like snowplows that sculpted the terrestrial planets. Interestingly, these models can also explain why we see hot Jupiters in many of the extrasolar planetary systems we have found, but not in our own solar system. That was a real surprise as we were discovering the first extrasolar planetary systems. We saw these Jupiter mass planets orbiting their star within what would be the orbit of Mercury in our solar system. And that was just a real surprise. Why is that happening? Well, so we have these 2 models. We have the Grand Tack model. Here, Jupiter formed rapidly beyond the frost line at about 3.5 AU. It's at 5.2 AU today, and began migrating inward toward the sun up to about 1.5 AU. These are all computer models that are simulating this under the influence of disk torques. In other words, that's interacting with the disk material and it's losing angular momentum. When Saturn formed later, a little bit later, and caught up, their orbital resonance reversed Jupiter's migration, sending both giants back outward. This tack, if any of you are sailors, you know about tacking, this motion, explains why Mars is so small and why we see relatively few inner planets, like many extrasolar systems. Jupiter's inward sweep truncated the supply of building material in the inner disk. So during its inward movement, Jupiter scattered material, scattered asteroids and rocky debris, both inward and outward, creating a wide range of orbital eccentricities for these small bodies. This is consistent with the asteroid belt as compositionally diverse and relatively depleted. So that's the Grand Tack model. The Nice model, which is named after the city in France, Nice, France, where it was developed, takes over where the Grand Tack model left off, describing gas giant migration starting at about 500 million years to 800 million years. It does a good job explaining the architecture of the outer solar system. For example, the 4 giant planets initially formed in a compact configuration, according to the Nice model. and later destabilized through mutual orbital resonances. In other words, their gravity was affecting each other as I guess that would be a four-body problem. That's completely unknowable, but never mind that. This triggered a dramatic period of outward migration and scattering, sending icy bodies inward as the late heavy bombardment, and we're going to remember those words, we're going to talk about them in just a moment, the late heavy bombardment, shaping the Kuiper belt and flinging bodies into the Oort cloud. Uranus and Neptune are among the most puzzling planets in the solar system because their present locations are difficult to explain using classical planetary formation theory. At their current distances from the sun, there probably was not enough time or material for them to form before the solar nebula dissipated. Most modern models propose Uranus and Neptune formed much closer to the sun, probably between 10 and 20 AU, possibly even closer. So now they are at, see, Saturn's 10. So Uranus is at 20 and Neptune's at 30 AU. They are believed to have been flung or pushed into the outer solar system, according to the widely accepted Nice model of planetary migration. As Jupiter and Saturn migrated, they caused gravitational chaos and sent Uranus and Neptune flinging into higher orbits. Some simulations with the Nice model suggest that Uranus and Neptune may have swapped places, right? So that Neptune was originally closer to the sun than Uranus, moving from their original spots into their current positions in the outer solar system. This dramatic reorganization of the solar system is believed to be the cause of the late heavy bombardment. So that's the second time you've heard that phrase. So let's talk about it. It is believed that around 4 billion years ago, our young inner solar system underwent a cataclysmic pummeling by asteroids that carved huge basins, for example, in the moon. This is called the late heavy bombardment, which proposes that a sudden change in the orbits of the giant planets Jupiter and Saturn, as well as Uranus and Neptune, specifically the inward migration of Jupiter and Saturn, disrupted the asteroid belt, sending asteroids crashing into the inner solar system. Among the evidence for this period, thought to have lasted somewhere between, this seems like a large range, but somewhere between 20 and 200 million years, are the scarred faces of the moon, as well as Mercury, as well as Venus, the distribution of asteroids in the asteroid belt, and the dates of impact melt in lunar rocks that are brought back by the Apollo missions. So when Apollo astronauts visited the moon, they brought back rock samples containing impact melt. This is a type of rock that only forms when material melts instantaneously upon being struck by an impactor. Scientists found that many of the samples, despite coming from different locations on the near side of the moon, had similar ages of roughly 4 billion years. So that pegs roughly pegs the age of the late heavy bombardment, with very few samples showing older impacts. This potentially indicated the period of increased and dramatic collision in the solar system. And I'm going to stop there today. This is kind of the framework that we will use next week to start understanding each of the planets, how they formed, why they look the way they do, and why in some cases they seem to be out of place. And I guess I should show my references today. It's a complex topic. I've got everything from my planet cup here, and I just copied off the cup. So it's pretty easy to do the presentation.
Lou, thank you so much. That was really, really interesting. Fantastic stuff. So very, very interesting. Viewers, if you have any comments for Lou, any questions for Lou, please put them in the comments, and we'll carry on next week. Stephen Hawking's on the BS. Nice to see you back, sir. I hope everything's okay with you. He has something for you. Thinking back, I remember a surprisingly large liquid metallic core within Mars. That must suggest something on collisions.
I'm not sure about a large metallic core within Mars. Dave, do you know it? Does this ring a bell?
Yeah, for you? Yeah. There is something. There's an idea now that what they originally thought was a liquid core on Mars, now that they have a little more seismic evidence from the InSight mission, may be a lower part of the mantle that's around the core, that's actually partially molten itself and is imitating a liquid outer core. I'm not sure if I have that exactly right, but I think that's there's now a very wide range of estimates for what the Mars core might be, just because they think that basically part of the mantle is actually, acting like a liquid core, seismically and yeah. So right. So I think the jury's still out on that, I think.
So if you had a liquid outer core, and if it was metallic, then I would expect a global magnetic field.
Indeed.
Maybe.
Mars rotation rate, at least the solid rotation rate, is about what Earth's is, and
right.
Some sort of convection must be taking place.
But Mars does have a trace magnetic field in some areas, doesn't it? It's not global.
It used to have a global magnetic field, I guess. Yeah. And it's frozen in some places.
Yeah, that's right.
Right. It does not anymore, but
MGS dragged a magnetometer kind of across the surface, so to speak, and identified the frozen in magnetic directions in the surface.
Yeah.
We call them magcons, I think, right?
Yeah.
Magnetic concentrations.
Yeah, but they right. Anyway, I should look this thing up, make sure I have the story right about the mantle. But I think at least part of it is that they do think that it's possible that part of the Mars mantle is actually imitating a core. So
yeah,
I'll look that up though.
Yeah, thank you, Dave. Thank you, Barry, for your donation. Much appreciated, sir. Fred says maybe Uranus and Neptune weren't flung out. Perhaps they waltzed out or cha-cha.
They sashayed out. Yes, that's true.
That. Okay, I mentioned the Nice and the Grand Tiger. That's the Fred Astaire model.
Oh yes,
planetary migration.
Yes, absolutely. Okay, and also Anne says she loves your mug. That's your coffee mug, not your face, I presume.
Well, I'm sure she means my face. Possibly means my face. Yeah, it is a pretty cool mug. And it turns out when you have, so right now you just see the planets. But when the hot coffee is put in it, when a hot anything, then I can see all this great information. I can see the solar nebula and everything that was in the presentation.
Yeah.
It just writes itself.
It just writes itself.
I'll have some of what you're smoking, Lou, definitely. So there we are. Okay, well, what we can do now is just what's coming up. Don't forget, on Thursdays we publish a weekly video, which is Space News Weekly. We're putting all the latest space news into its separate program. And I publish that on Thursday, at some point in Thursday evenings. I'm afraid I can't guarantee to get it there at a particular hour. Sometime Thursday evening, we publish the video, and it's all the latest space astronomy news. We hope that you will watch the video. And we did start it as a bit of an experiment, so show it some love, because we'd like to see it succeed. And if you do want to keep up to date with the very, very latest news, then watch Space News Weekly on the channel from Thursday onwards, and thank you very much for that. So what we're going to do now is to move to our penultimate feature for this evening, the welcome return after a brief hiatus of Einstein of the Week, our weekly delve through the dense thickets of ignorance on social media. And let's have a look and see. I've only got a few for you this week, but trust me, these are beyond wacky. So first one, the only comment you can make here is right. It's all about NASA submarines. Did you know about NASA submarines?
Lou, they found out about the submarine.
We're not, Dave, we're not allowed. We can't really discuss that.
Really.
Yeah. So
we're going to have to cut you off right here, Andy. I'm sorry, but you have to stop.
Censor.
So anyway, this is very, very interesting. NASA stopped exploring the ocean because they found the Leviathan.
Oh boy.
Oh, look at that NASA emblem on the side.
I know. Cute little NASA logo on the submarine. Love that.
And you can kind of date it because NASA goes back and forth using the worm.
Right. Right.
And then the what's the other one?
Well, that's the meatball, right?
The meatball.
The
That's what they call
meatball.
this one, the meatball.
Yeah.
So it's the meatball. So it must have been before the mid 70s, right? Or the 1980 roughly that they started with the
Yeah,
the
the
worm.
80s, the worm, yeah.
Yeah.
Yeah. So there you are.
In fact, they might have been inspired for the worm by seeing that Leviathan thing. So
Absolutely.
there you go. You can add that to the conspiracy.
Definitely. Beyond this one's beyond hope. How long do people fly upside down when going across Antarctica?
I like that.
Yes. Yeah. I mean, what can you say about that?
This is consistent. There's actually, I'm not sure if I mentioned this before, there's actually a developmental model for young children where they put a picture of the Earth in front of them and they give them little people to put around the Earth, little that they can, stick on the picture. And up to a certain age, all the people they stick around the Earth are standing straight up. And then after a certain age, their head and feet are pointed, towards the center. So this person must be, 4 or 5, I would guess.
Yes, I guess it's a flat Earth thing, as you might guess, because flat earthers think that literally people in the southern hemisphere are upside down. And, and I said to one of them, but my sister lives in Australia, and I can assure you that she's not upside down. And he said, well, Australia doesn't exist. A lot of these flat earthers really believe that Australia is fake, that it doesn't really exist.
The Australians get upset with us when we say things like that because they say we're very northern hemisphere centric. In other words, we could easily be upside down and they're not, that kind of thing.
Yeah. Barry says there's a common misconception that Australians are upside down. That's completely false. They do walk on their hands, though. Yeah. And Stephen Hawking's on the beers. You've nailed it, sir. Oh no, Phil, flat Earth incoming in the ice wall. Yeah, you got it.
Yep.
So, okay, last one today. I think I've got 3 today, but this one is worth the wait. I'm going to read it to you because it's quite long and it might not be that visible on your screen, especially if you're on a phone. Let me read it for you. This is all about a really interesting topic: cats and aliens. Let's just get rid of this.
Nothing wrong with cats.
No, well, you might think otherwise after reading this, Michael. Okay, so here we are. Here's the thing. The Egyptians knew the Earth is actually flat many thousands of years ago, and you two can also witness this even right now. It's very simple and will make you wonder, and more importantly, open your mind that most likely has been switched off from the truth by the sounds of time. Have you ever seen a cat tilt its head to one side and seen it staring towards the sky with its ears moving backwards and forwards as if their ears are tuning into a frequency that you cannot hear or understand? Cats are in contact and communicate with many of our star-being neighbors. Star beings all over the many universes are well aware of our Earth's flatness and have even been in contact with us to let us all know the real truth about our home planet. They've been actively showing us all for thousands of years that Earth is actually flat in the form of crop circles. That's why all crop circles are flat. The Egyptians knew this for thousands of years, and it's the only reason they were cats.
What do you say to that?
There's a few flaws in there.
Just a few.
One is that the only reason that they worship cats demand to be worshipped. So it actually has nothing to do with Earth. And everyone knows that about cats.
That is true.
Yeah,
But I
that's
like all crop circles are flat. What are they supposed to do if you have a field of crops? How do you make it not flat?
Yeah,
I don't even understand.
I asked myself that question. What is a non-flat crop circle? How does that work?
Right. What would that look like? I have no
Well,
clue.
they're not making crop circles on rolling hills, obviously.
I guess.
Yeah. So anyway, that's Einstein of the week for
Wow.
this week. It gets worse, doesn't it? There is no hope, is there?
Well, I have to love how that a lot of times these arguments are like, well, look back, the Incas knew that the Earth, or the Egyptians knew this, or thousands of years ago they knew this stuff, and I'm like, I don't say that's an argument, because I think we've learned stuff in the last few thousand years. I think that's kind of the point of. So I just wonder about this, looking back at ancient cultures and saying, well, look, see, they knew this, and now we're wrong. I don't get it, but okay.
Yeah, I know. And Fred says most or all of the lines of the Santiago Chile Metro subway run on rubber tires in deep cement grooves. Maybe if rails, it would derail since almost upside down. Yeah, yeah. So there. Yeah. And Deep Burrito, nice to see you, sir. Hope you're okay. Says hi all. Funny, I just came from a live podcast about hieroglyphs. Was it about cats? And Stephen Hawking on the beer says, I love watching Flat Earth channels. It's my guilty pleasure. Yeah, I have quite a laugh too. I can only take them up to a point before I start tearing what remaining hair I have out. So it gets a bit much after all.
I didn't know there was a Flat Earth channel.
Oh, there are millions of them, mate.
Are there really?
Millions of them.
Oh,
Millions. And there you are. Yeah, so there you are. So thank you all for your comments. We're going to move on now to our last feature for this evening, which predictably and even very inevitably, there's a certain degree of inevitability about it. And we have to go back to Roger for that, for Constellation of the Week. So
there we go.
I hope you're ready for this. Just let me do that for you, Roger. There we are. Okay, so
here we go. Yeah, we're off to Taurus. Well, it's sort of fairly topical, as it is still about at the moment, with Jupiter occupying that area, although that is actually in Gemini, but it's, you know what I mean. Right, so we've got 797 square degrees of the constellation with 19 main stars, 4 of which are greater than magnitude 3, and 2 Messier objects, including the Crab Nebula. More about that. More about that later. Spoiler alert. Okay, so I'm sure most of us know where Taurus is. Top left of Orion. Yeah, sort of on that ecliptic where there's those other 11 constellations of that reputation of star things. We won't go into that. So Aldebaran, the Alpha Aldebaran, is a spectral class 5 3 giant, magnitude 0.87. 65 million light years away, and derives from the Arabic Al-Daraban, the follower, as it follows the Pleiades across the sky. And Aldebaran forms the bloodshot eye, described as a glaring menace at the Hunter Orion, and is 116% of the mass of the Sun, and hosts a candidate exoplanet.
Ooh.
There we go. But we've also got the second brightest beta, El Nath, which is 1.65. Also designated Gamma Aurigae. So we've got another one which is in 2 constellations. And then we've got Tianguan, which forms the southern horn and has an eclipse in binary every 133 days. So here we have the designations and names of the stars and their distances. So they sort of vary between 65 light years for Aldebaran, going out to 417 for Tucuan. So quite an interesting variation on that. But everyone knows the Pleiades, the Seven Sisters, which is roughly between 500 to 1,000 stars, all about 1 million years old. So it's quite a young system, and includes all sorts of stars, brown dwarfs, white dwarfs, and the cluster is estimated to dissipate in about another 250 million years. So,
Did you take that picture, Roger?
I could say yes, but I'd be lying. I've taken many. I've taken many similar quality pictures, but I decided to use this one off the interweb. But also we've got the Pleiades, and then we've also got the Hyades. So that spans about 5 degrees of the sky as a distinctive V or a K asterism, and includes a naked eye double star, Theta Tauri, Chamunkukui, with a separation of 5 to 6 arc minutes. So have a look at that and see if you need to go to Specsavers. Right. So we've also got eclipsing binaries and a stellar prototype of the T Tauri, which has an interesting variance of a magnitude 9 to 13, and is surrounded by a nebula, which also varies in its luminosity as well, obviously because of the variable star there. So apart from the Crab Nebula, we've also got a crystal ball nebula. Get that one, Tom McCrory. That was discovered by William Herschel in 1790.
Wow.
But William Huggins used its spectrum to provide nebula is made of luminous gas, not unresolved stars. So there we go. And we've also
in his
got
Herschel catalog? I bet it is. Herschel 400, is it called? Something like that.
Might well be. I haven't got that information in front of me, unfortunately. Okay. But it's quite likely. I expect Caroline has catalogued it for her brother. And then we've also got the Tora Auriga complex, which is containing roughly 35,000 solar masses of material, spanning 98 light years. And at 490 light years, is one of the nearest active star forming regions. So there we are.
Wow.
So here we go. Everyone's well known with this, and is the start of the Messier catalogue. It was originally visible in historical text in 1054, and also North America indigenous art, which was found in New Mexico, and pottery fragments. So it wasn't actually not in. The remnant itself was not discovered until 1731 by John Bevis. At its peak, the supernova reached magnitude -4, but now it's only magnitude 8.4. So quite a variety of change in the brightness, and obviously, since photography was used in astrophotography, you can see the development of the expanding gases over the time that we have been doing photography of this object. And we've also got 2 meteor showers associated with Taurus. We've got the Taurids in November, and then we've got the Beta Taurids in June and July, because we fly through that in 2 different parts in our orbit. I'm assuming. So it's always been a bull since the Stone Age. The identification of Taurus the bull is possibly up to Upper Paleolithic. So it's originally drawn around about 15,000 BC and accompanied by the Pleiades constellation as well. So quite a lot of observations have been made of it.
Wow.
So in Babylonia, it was listed as Mole Appen, as the Bull of Heaven, marched from 4000 BC to 1700 BC. The Egyptians associated the sacred bull as a renewal of life in the spring, depicted in the Dendra zodiac. Its sacrifice as the sun covered it symbolized renewal of the land. And then the Hebrews were the first constellation, was the first constellation in the Hebrew zodiac, and represented by the first letter of the alphabet, Aleph.
I didn't know they had a separate zodiac. I
Well,
guess
there
many
we go.
cultures do.
Yeah.
Huh.
There we go. So we've had the Babylonian epic of Gilgamesh. The goddess Ishtar sends Taurus, the bull of heaven, to kill Gilgamesh for spurning her advances.
Ooh, hell hath no fury.
Oh, absolutely. There's always something upsetting somewhere else that needs something to be done about it, and this is what was done in Babylonian times. Some identify Gilgamesh as the neighboring constellation Orion, facing Taurus as if in a combat. Early Mesopotamian art, the bull of heaven is closely associated with Inanna, the Sumerian goddess of love, fertility, and warfare. And one of the oldest depictions shows the bull standing before her handstand with 3 stars on its back.
How do you get a god of love, fertility, and warfare?
Yeah.
Lou,
All's fair. All's fair in both.
Yeah, in love and war.
Common.
Yep. But
They have something in common.
Lou,
yeah,
you're a married man, Lou. You should know these things.
I am so happily married.
absolutely. But in Greek mythology, there was a mythology where Taurus was identified with Zeus, who assumed the form of a magnificent white bull to abduct Europa, a legendary Phoenician princess. Only the front half of the bull is depicted, sometimes explaining as Taurus being partly submerged, carrying Europa out to sea. And then we've got Io and the Cretan bull. As the second myth portrays Taurus as Io, a mistress of Zeus, transformed into a heifer to hide her from Hera. The Greek mythologist Acilius also links Taurus to the Cretan bull, one of the 12 labors of Heracles. So it's all going on, isn't it? So, but then a bit nearer to home, we've got the Druids became an object of worship. The Tauric religious festival was held while the sun passed through the constellation. And then we've got the Inuit called Skiatatat. The Hyades, Norajak, represents the spirit of the polar bear, while Aldebaran as the bear, and the remaining Hyades stars as dogs holding it at bay. And I'm sure that would make an interesting story. But Buddhism legends hold the Gautama Buddha was born on a full moon, was in Taurus. On Buddha's birthday is celebrated with a Wesak festival occurring on the first or second full moon when the sun is in Taurus. There we go. But this is an interesting fact some of you might know. The 1919 solar eclipse was on May the 20th in the Hyades cluster, including Capitoria, where photographer Arthur Eddington expedition in Principe and a team in Sobral, Brazil, their observations confirmed Albert Einstein's prediction of the bending of light around the sun, as described in his general theory of relativity in 1915. So it's one of the most celebrated confirmations in the history of science. So without
Yeah,
without
yeah.
that, they would have had to wait a bit longer. But the what was fascinating in this picture is the size of that prominence across the surface there in the northeast there. I don't know whether that's an actual representation or whether AI has added that. I don't know, but it's quite interesting. But we've also got Pioneer 10, which is moving in the direction of Taurus, although it will be a little while longer before it gets there, unfortunately. But we've got the astrological Taurus, which is the sun between May the 13th and June the 21st. And then we've got the precession of equinoxes, which the sun's position on the 21st of June 1990, it crossed from Gemini into Taurus. It moves through Taurus at least 1 degree east every 72 years. So until 2600 AD, when it will become in Aries on the first day of summer. So there we go. And finally, we've got just some historical interest of what we have here on the what we've heard already earlier on today. So there we go. So whether there might be some interesting facts there or not, you might not have heard of the constellation of Taurus.
Thank you very much, Roger.
Okay.
Absolutely. And well, we must at this point say happy birthday to Sandra for tomorrow, because Taurus is her birth sign, obviously. So happy birthday to Sandra for tomorrow. I hope you have a fantastic day, Sandra, and thank you so much for being here. And I must also say a special thank you to Deep Burrito for your exceptionally generous donation, sir. It's very, very kind of you. That will really help us out, and it's much appreciated. And it's good to know that you're all appreciating what we do at Space Oddities, all those who give us money. I'm not saying those who don't give us money don't appreciate us, of course, because everybody has financial restrictions in these days. So we'd like to say thank you to all of you for being here, of course. But anyway, Deep Burrito, thank you very much indeed, and that really is very useful to us. So thank you. All right. Well, that brings us to the end of Space Oddities for this evening. We did have this crazy idea of restricting the length of our live streams, but I see we've gone over 2 hours again.
We keep trying, but
Did try.
Yeah.
Try, but we will continue to try, and there we are. But we hope you've enjoyed the show, and we hope you stayed with it from the beginning. And we had a few people turning up a little late, see me after class, so we hope you can watch the whole thing at some point. Don't forget, it's on YouTube. If you are watching us on the channel at the moment, if you click the posts tab on the channel, I've put today's question in there. Which destination in the solar system do you think should be explored next? Click the comment icon. Tell us what destination and why you've chosen that. Let's get a little conversation going. Let's see if we've got any unusual choices. So click the posts tab on the channel and answer the question you've been told. So there we are. So I'll be back with Daz on Thursday for Space News Weekly, and that will be published. We record it Thursday afternoons, and I put it up on the channel sometime Thursday evening. We hope you'll join us for that, for the very latest space news. And next week, Lou will be carrying on telling us all about planets and how they're formed, and we'll have some more hopefully interesting stuff for you as well. So from all of us at Space Oddities, thank you so much for being here. We do appreciate it. And have a fantastic week, everybody. Be good, and if you can't be good, be average. And look after each other, stay safe, and we'll see you next week on Space Oddities. But don't forget Space News Weekly on Thursdays. All right, then, take care. From all of us, good evening.